Hey fellow problem solvers, Colfax Math here. Today I'm going to do a quick overview on the derivatives for a calculus class. There are 4 different rules we're going to look at in derivatives: the power rule, the product rule, the quotient rule, and the chain rule. Again, this is for a calculus class, and what the derivative is if I have a function, any function y equals f of x, I want to look at the slope of that function, and I can see I have a positive slope until it gets to a point, and then there my slope is equal to 0, and then I have a negative slope. The derivative tells you the slope of that function. So even if you're in a pre-calculus class, the reason why you spend so much time looking at slope is so that you could do calculus later on. The way you get good at any math, just like juggling, is with practice. So just a couple quick notes first. Make sure you simplify your function before you start looking for the derivative. Remember, write down every step pretty clearly so you don't make any mistakes. The derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. The derivative of e to the x is e to the x. It is the only function where its derivative is equal to itself. However, e is only a number, 2.7. So 2.7 to the power of 2, that's just a constant, and that constant will be equal, the derivative of that constant will be equal to 0. The derivative of the natural log of x is equal to 1 over x. A lot of ways to write the function. Most common is f of x. The derivative could be written f prime of x or dy dx, and that stands for the change delta y over delta x, change in y over the change in x. All right, so the first rule we're going to look at is, the derivative of x is equal to nx to the n minus 1. And what that means is, if I have x to the 5th, that is my function. Its derivative, f prime of x, that comes down in front to give me 5x, 5 minus 1 to the 4th. Pause the video, do these 2 problems, unpause, and watch how I do them. Okay, if f of x is 3x to the power of 4 minus 5x to the power of 2 plus 7x minus 2, the derivative, f prime of x, is equal to 12x. 4 minus 1 is 3. Minus, that 2 comes down, minus 10x to the first. This is x to the first, so it's going to be 7. 1 minus 0 is 0. Anything in 0 powers equal to 1. So the derivative of this function is that right there. This problem's a little different. In this problem right here, I'm not taking a derivative yet. I am just rewriting it. G of x is equal to 2 times radical x. Well, any radical is the same thing as a half exponent, so it's 2x to the 1/2 plus 1 over x to the 3rd, which is the same thing as x to the negative 3. So this is still my function. The only difference is now everything's in the numerator, and I have exponents instead of square roots. So if that's g of x, g prime of x, the derivative of that is 1/2 comes down in front to give me x. X to the negative 1/2. Oh, sorry. This is 1/2 times 2 is 1. X to the negative 1/2. And then this negative 3 comes down in front to give me negative 3x to the negative 4. My final answer does not have fractional exponents or negative exponents, so I rewrite that derivative as 1 over the square root of x minus 3 over x to the 4th. So again, that's the power rule. Let's now take a look at the product rule. So the product rule's starting to get a little more complicated here. So h of x is made up of h of x is equal to one function, f of x, times another function g of x, then the derivative of that is the derivative of the first part times the second part plus the first part times the derivative of the second part. Okay, so this is my first part, this is my second part. So h prime of x here is going to be equal to the first part derivative. I got to use my power rule here. So this is equal to 2x to the first. That's the derivative of the first part times the second part. Second part is 3x minus 2 plus the first part, x squared plus 1 times the derivative of the second part. Derivative of that right there is just 3. Need to expand that. It's still my derivative. 2x times 3x, 6x squared minus 4x. Distribute that 3 through the quantity. 3x squared plus 3. Then I have to combine similar terms. So the derivative of h of x is equal to 9x squared minus 4x plus 3. Again, pause the video. Do the problems before I do them. We're going to find the derivative of kx here. It is one function times another function, f of x times g of x. Remembering that the derivative of sine of x is cosine of x. So k prime of x, the derivative of k of x, is going to equal the derivative of the first function, just 1, times the second function, sine of x, plus the first function times the derivative of the second function. Derivative of sine of x is cosine of x. In that derivative there's really nothing that you could pull out, no way to simplify it. So that's the derivative. Okay, moving on from there, we are now looking at the quotient rule. So on the quotient rule here, if my function h of x is equal to one function f of x divided by another function g of x, its derivative is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So this is my numerator, this is my denominator. So p of x is equal to this. So p prime of x, its derivative, is going to be equal to the bottom term, right? X minus 1 times the derivative of the top term. Derivative of this is just 1 minus the top term, x plus 1, times the derivative of the bottom term, which is 1, all divided by the bottom term squared. So x minus 1 squared. That's the derivative. I'm going to simplify that to x minus 1. Distributing that negative through the quantity minus x minus 1, all over x minus 1 squared. My numerator is going to be x minus x. They cancel. Negative 1 minus 1, negative 2 over x minus 1 squared. And then that can't be simplified. That's as far as I could go using the quotient rule. And then here's a second problem. Now my numerator is a trig function divided by an x. We're going to still use that quotient rule there. So we're going to take the denominator, g of x. So my function is q of x. So my derivative, q prime of x, is equal to the quotient rule of the denominator, x, times the derivative of the numerator. Derivative of cosine x is negative sine x. I'm going to put that negative out front. Negative sine x minus the numerator, cosine of x, times the derivative of the denominator. Derivative of 1x is just 1. All divided by the denominator squared. The denominator squared is x squared. Same thing here. I can't cancel anything or pull anything out. Okay, lastly, let's take a look at the chain rule. Okay, now we're on the chain rule. The chain rule is if h of x is a composite function, f of g of x, then you take the derivative of f of g of x and multiply it by the derivative of what's inside. So on number 4 here, again, pause the video, do the problems first. Let me just write this out. This is my function r of x. It is equal to 2x plus 3 to the power of 5. So r prime of x, the derivative of r of x, is equal to 5 comes down in front times the same thing inside, 2x plus 3. Subtract 1 from there to get 4. And then the chain portion of it, now I multiply by the derivative of what's inside, which is just 2, right? This 2x to the first is 2 times x to the 0. Just to clean up that derivative a little bit, gives me 10, 2x plus 3 to the 4th. And then right here, on problem number 4, find the derivative of this composite function, sine of x squared. Inside my composite function, g of x is going to be x squared. So the derivative, s prime of x, is going to be the derivative of sine, cosine of x squared, times what's inside there, times 2x. I don't really want to leave that 2x out in the front because it looks like cosine of that whole quantity. So I'm going to rewrite this as 2x cosine of x squared. Last problem, find the derivative of e to the power of 4x to the first. This one right here is going to be t prime of x is going to be equal to this function itself, e to the power of 4x minus 1. The derivative of e to anything is itself. It's the only one that does that. However, because there's a function inside the function, I have to take the function of this inner term here. And the derivative of this is just 4. So I multiply it by 4 or put that 4 up front. Quick overview of the 4 rules of taking derivatives with sample problems.